Hello everyone, I am Mohammad Asif. Hope you are enjoying happy and good health. We are going to start our new chapter for O-level chemistry. The heading of the chapter is Ammonia and its uses. The chemical formula for ammonia is NH3. This is the chemical formula for ammonia. From this formula, it is quite clear that ammonia is the binary compound of nitrogen and hydrogen. The central atom is nitrogen. Actually, nitrogen is fifth group member, and it was called initially nitrogen was called as azote. That was called azote mean without life. But in actual practice, the whole life depends upon protein, and the main constituents of the protein is nitrogen. We know that nitrogen has 7 proton number with 2 and 5 electronic configuration. If we discuss the geometry of the ammonia molecule, there are 4 pairs of electron around nitrogen. 4. Out of these 4 pairs of electron, 3 are bond pairs and 1 is lone pair. Depending upon the electron pair geometry, there should be an angle of 109.5 between its bonds. If these are the 3 bonds, and according to 4 pair of electron at 4 corners of a regular tetrahedron, there should be an angle of 109.5. But due to the presence of this lone pair, the bond angle decreases and it becomes 107.5. 3 of them are bond pair and 1 is lone pair. This lone pair changes the geometry of the ammonia molecule. Now, we know that in atmosphere there are 3 main gases. The first one is nitrogen, which is 78%, then is oxygen, which is 21%, then is carbon dioxide 0.04%, and some of the trace gases are also present. This is the composition of atmosphere. Due to the presence of triple bond in a nitrogen molecule, due to this very strong triple bond, the nitrogen molecule or nitrogen gas behave as just like an inert gas. In so many cases, this gas does not react normally at normal conditions of temperature and pressure and behave just like inert gas. But when drastic conditions are applied of temperature and pressure, then nitrogen can react with other elements. From all of these, oxygen is the most reactive, then carbon dioxide, and then nitrogen is least reactive. That's why the nitrogen is considered as like an inert gas. Now, the percentage of nitrogen remains 78% in the atmosphere at constant rate. Why? The percentage of oxygen, percentage of carbon dioxide remains the same in the atmosphere. Why? Because there is a nitrogen cycle which maintains the percentage of nitrogen at 78% in the atmosphere. Similarly, there is oxygen cycle and there is carbon cycle also. Now here we are discussing how the atmospheric nitrogen change into different its compounds. The conversion of atmospheric elemental nitrogen into its compound is called nitrogen fixation. And this nitrogen fixation takes place as it is explained in this nitrogen cycle. If we start from here, the atmospheric nitrogen is least reactive, but when lightning takes place, a high electrical charge is produced, due to which a high temperature produces, which compel both of these gases to react, and both nitrogen and oxygen reacts together to produce oxides of nitrogen. And then these oxides of nitrogen dissolve in water and change into soil nitrates. Soil nitrates. On dissolving these oxides of nitrogen, these are changed into soil nitrates. Now, the soil nitrates are, with the help of leguminous plants, atmospheric nitrogen can also be directly converted into soil nitrates, or the oxides of nitrogen on dissolving in water can also be changed into soil nitrates. Now, these soil nitrates can be directly changed back into atmospheric nitrogen. Now, if we look at this side, atmospheric nitrogen can be converted into ammonia using a Haber process. Haber process is the process in which we react both nitrogen and hydrogen to produce ammonia, which is a nitrogen rich chemical compound, and which is used as a source of nitrogen, as a fertilizer for the plants. Now, this ammonia, by denitrifying bacteria, can be changed back into the atmospheric nitrogen. Now, this ammonia can also change into soil nitrates. Now, these soil nitrates are absorbed by the plants through their root hair system and change into plant protein. This plant protein is then eaten by animal and then changed into animal protein. Now plant protein and animal protein both can be converted directly into ammonia. In this manner, this whole cycle remain continuous all the time, maintaining percentage of nitrogen in the atmosphere at a 78% fix. This is called as a nitrogen cycle. Now, from this cycle it is quite clear that atmospheric nitrogen cannot be changed into proteins by the animals. Animals are unable to change the atmospheric nitrogen into the proteins. So, to help animal, first of all, soil nitrates are converted into plant protein. Those plant proteins are taken by animals, converted into animal proteins and then into ammonia. It means that the production of this plant protein, this is much more important because this animal protein cannot be synthesized directly from the atmospheric nitrogen. That is quite difficult. So, for the plant protein, nitrogen is essential and plant protein production is most important for the sustainability of life. So, when repeated cultivation of crops takes place on earth, the plants absorb nutrients for the growth and gradually the soil become deficient in those substances which are useful for the plant growth, essentially which is nitrogen. To make up the deficiency of the soil, we use ammonia as a fertilizer. Now, ammonia was first synthesized by Fritz Haber, and got Nobel Prize for the production because using Haber process, we produced ammonia in such a large quantity which can be utilized for the barren soil and for the soil which are deficient in the substances required for the plant growth, to grow more and more food for the vast population. In the absence of this ammonia, that might be a deficiency of food for the whole population of the world. So ammonia is the most important fertilizer which increase the rate of production of plants and provide the maximum nitrogen. How we can say that the ammonia is providing maximum contents of nitrogen? This can be done by calculating the percentage of ammonia. How we can find out the percentage of ammonia? If we calculate the molar mass of ammonia, that will be equal to 14 multiplied by 1 plus 1 multiplied by 3. Mean 14 plus 3 is equal to 17 gram per mole. This is the molar mass of ammonia. Now, what is the percentage of nitrogen? Percentage of nitrogen is 14 divided by 17 into 100. This is the method to calculate the percentage. This will gives us approximate answer. This will give approximate answer that might be 1400 over 17, approximate at 87% approximate. This is the percentage calculated from ammonia, the percentage of nitrogen. This proves that ammonia has a maximum percentage of nitrogen that can be provided to the soil for the production of plant growth. Now, this is a nitrogen cycle in which all the processes are taking place, and this nitrogen cycle is responsible for the conversion of the nitrogen or nitrogen fixation in different chemical compounds and then back into the elemental nitrogen once again. I have explained nitrogen cycle completely and all the associated relevant information about the nitrogen and ammonia. Hope you have understood all the concepts. In case of any problem, you can write the question at Study of Change page.